Audio Jungle. Audio Jungle.
Here we have a doublet in uniform flow, or you can write flow. You can write flow past a circular cylinder. Flow past a circular cylinder. This flow past a circular cylinder, as I told you, there is no physical body like circular cylinder, or there is no physical body like Rankine half body. There is no physical body like Rankine full body, oval body, something. It is not physically available. Actually, it is the fluid made surface. It is fluid made imaginary body. Means fluid will be in such a way that you will get oval body shape. Fluid flow fluid flow in such a way that you will get circular cylinder, but there is no physical existence of it. Okay. Now, how you will achieve this flow past a circular cylinder? Suppose you want achieve this circular cylinder flow, then how you will get it? So for that you will have a superimposed flow. What that superimposed flow you should have? It should be a doublet flow. It should be a doublet flow. Okay, you should be a doublet flow. You should be a doublet flow plus uniform flow. Okay, if you have doublet flow and uniform flow, this combination will generate circular cylinder. This combination will generate circular cylinder flow, or also you can say flow past a circular cylinder, something like this. If this is now the circular cylinder, something like this. If this is the circular cylinder, so you may have flow like this, flow past a circular cylinder. So this circular cylinder or cylindrical surface you will get, but it's a imaginary fluid made flow. Okay, we do not have any physical existence of this circular cylinder. uh, this will be a fluid made, okay, imaginary surface you will get. The shape exactly you will get like a circular shape, but it's a fluid made, it's a imaginary, it's not a solid surface. But all theory will work. We can consider this is the cylinder or circular cylinder, or this is the circular shape, and we have to use this concept with the help of the streamline basic concept, like streamline are not going to intersect with each other. Okay, and if you see, one imaginary surface will be made because of this combination, where the flow is what not going to cross from inside flow to outside or outside flow to inside. So one imaginary surface will be created. Okay, I will show you that pattern. So flow past a circular cylinder. Here cylinder is not rotating. Okay, only we will get a circular shape. That's all. So now if I show you all the patterns, so first you have to draw the uniform flow here. See, first you have to draw the uniform flow. Like this is nothing but uniform flow. And uniform flow, as I told you, three types of uniform flow you can have: parallel to x-axis, parallel to y-axis, and inclined flow. And inclined flow. So this is the parallel to x-axis. This is nothing but uniform flow. This is nothing but uniform flow. Uniform flow. Anyway, then we should have a doublet flow. Doublet flow, you know very well. It's nothing but it's a combination. It's a combination of source and sink. Both source and sink have a equal strength. Okay, and very important, when I have taught that doublet flow, that time I have told you distance between the source and sink tends to zero. If we have source and sink, then distance between source and sink tends to zero. Then that time we achieve the doublet flow, and that doublet flow was something like this. So I will show you the doublet flow here. If source and sink distance tends to 0, it means it is going to exist at the same point. So if source and sink will exist at the same point, then how that shape will be. Okay, already I have taught you that doublet flow. You can see doublet flow if source and sink both are existing at the same point, or you can say that distance between source and sink tends to 0. So the flow pattern for the doublet flow will be something like this. If you turn the pages, you will get it. This is now source started from this point, and here this is nothing but sink. Source will generate the flow will be coming out from the source, and sink is the absorbing the flow, or sink is the point where the flow going towards the sink. That's the mean of it. So going outward and going inward, because source and sink are existing at the same point, because distance between source and sink approaches to 0. So this is all about source, and similarly here downside also you can show this is nothing but source, this is nothing but source, and this is nothing but sink. Towards sink flow will be absorbed, something like this. So this is what doublet flow. Okay, so once you take the combination of source, once you take the combination of uniform flow and doublet flow, this is nothing but doublet flow, like sorry. So this is nothing but doublet flow. Okay, this is nothing but doublet flow. So both source and sink are existing at the same point. You can say source and sink distance is what approaches to 0, hence almost it will exist at the same point. So doublet, this is nothing but doublet flow. Okay, this is nothing but doublet flow. Doublet flow. All right, now if you draw the exact flow pattern for this, okay, I mean once you combine this uniform flow and a uniform flow and this doublet flow, then what will be the combination and how it will appear. So it will appear like this. Okay, we'll draw the axis along the direction of uniform in horizontal direction. X-axis will be there and vertical axis also will be there somewhere. Okay, now if you see, this will be continuous. Okay, this will be continuous, and you can think, because source flow, if you check here, it is source flow. See, I will show you like this. This is the source flow, and similarly here also the source flow. Huh? And this side uniform flow is what coming. Okay, this side uniform flow will be coming. So somewhere here we will have a stagnation point somewhere here, because source flow is what just opposite to uniform. It is coming outward. So strength of source, as I have explained you, strength of source and sink both are same. Only just magnitude wise it is same, but direction wise it is just opposite. So for the source flow, it is just coming outside, and obviously right to the doublet, if you see, we have a uniform flow. Uniform flow is what? Flow is what coming towards the source, and source, it is coming outward, because source is nothing but outward flow. So somewhere it will meet source flow and this uniform flow. Once it will meet somewhere, so definitely it will have a zero velocity. Zero velocity will exist somewhere. So I believe that at this point it is getting zero velocity. Okay, so you have to draw one, sorry, you have to draw one, because if you continuously, if you see the pattern, so this pattern is what going to change into one circle, changed into a circle. Like just before that you had seen the Rankine full body. So in Rankine full body, what was the combination? So combination was uniform flow plus a source and sink pair. So there also I had shown you stagnation point, two stagnation points. So similarly here also we'll get a stagnation point. But what is the difference between Rankine full body and this uniform plus doublet? Instead of source and sink pair, we are going to take doublet flow. Doublet is also a special pair of source and sink. There was source and sink was placed in distance 2a, but here source and sink distance is what almost eliminated, so it is existing at the same point. So for that reason, because source and sink was 2a distance apart, so that time you got oval shape. Now if you 2a distance you approaches to 0, if you show 2a distance approaches to 0 for a doublet, so oval shape will be shrinking now, and now oval shape will be converted into circle basically. So same, just like a Rankine full body you had seen, we have for the uniform and doublet combination also. So instead of oval, now you will have a circular shape, because if you check the overall things here, once you overlap this uniform to this doublet, so one stagnation point you will have here and another stagnation point you will have here. Now the complete circle you will get here with this combination. Instead of oval shape you will get complete circle. Now oval shape you had seen in case of the Rankine full body. Now in case of the Rankine full body, why oval shape that time you got? Because source and sink pair was 2a distance. uh, Distance between source and sink was 2a. It was uh, aparted by 2a distance, but now it's completely gone. It is approaching towards 0. So this complete circle you will get. Okay, this complete circle you will get something like this, something like this. Rest, as I had explained in case of Rankine full body also. Similarly here also this circle, because this one is the stagnation point here. This one is the stagnation point, and here also will have a zero velocity, because all the flow will be sinking here. Okay, will be sinking because of the this point, because we have a sink here, so all the flow will be sinking here. So obviously somewhere will be there will be point near to sink where velocity will be 0, because all the flow will be sinking at this sink point. So definitely the flow velocity reduced to 0. Okay, somewhere, which is exactly not at the sink point, because at sink flow will continuously be sinking. There will be a velocity, radial velocity will be existing at the sink, but near to sink somewhere one point will be there where velocity reduced to 0. All flow will be synced by the sink point, hence near to that one point will be there where velocity will be uh, reduced to 0. That point will be the stagnation point. So here this stagnation point is nothing but, this is the one stagnation point. Okay, and here also we have one stagnation point. And if you show the exact pattern, then uniform flow will be continuously something like this, something like this. It will be continuous like this. Okay, this is the case flow passed over circular cylinder, something like this. Flow will be continuous like this. So here this surface, blue one, this surface will be treated like a solid surface. Okay, but it doesn't mean it's a solid surface. It's a fluid made imaginary surface. Okay, because inside we have a combination of doublet flow and outside we have uniform flow. As you can see here, source and uniform, if you see, source is what continuously coming outside, and uniform flow if you see coming towards the source side. So somewhere it will meet and it will have a stagnation point. It will have a stagnation point, means velocity will be 0. So I can say this S1 we have a stagnation point here, and this is the S2 and S1. Okay, and this inside surface, which is the zone of the doublet, and
So your voice is not audible.
Now it's uh,
हाँ sir, but it is very low.
now it's fine. Now
हाँ
it's
sir.
right. So that's the reason, it because it is passing through the stagnation, because this these all are streamlines, right? These all are streamlines, and but this blue streamline is passing through the stagnation point, hence it is called as a stagnation streamline. And obviously for the because it is passing through the stagnation point, this line is what passing through the stagnation point, hence if you write the equation for the stream function, then it will be 0. I will show you why it will be, because what is the psi is nothing but a stream function, and it this change of stream function, that psi2 minus psi1 that I had explained already. So existence of the stream function means there is the case of the possible flow. But if you see for this blue line, there is no uh, flow across this blue line. Okay, there is no possible flow across this blue line. It means, because psi is the stream function, if a stream function is what existing, it means there is the possible flow. But as I have explained you, this blue line is what treated as a solid surface, and these line are preventing the uh, flow from inside to outside and outside to inside. That flow is what not possible, means along this blue line flow it cannot cross. It means there is no existence of the stream function here, because flow is what not possible across this blue lines, right? For that reason, if you write this equation of streamline for this blue line, so it will be automatically 0. It's a self I mean, you can easily understand this, because stream function is nothing but the existence of a stream function is nothing but possible case of the flow. But just now I had explained, this will be treated as a solid surface, that flow is what not going to penetrate, this flow is not going to cross this. It means stream function will be 0. This is also one marks question they can ask to you. What will be the equation of streamline for flow past a circular cylinder? Okay, or they can also ask, what will be the uh, what is the equation of streamline which is passing through the stagnation points? If they are because these all are multiple lines we have can see here. See, this is the streamlines, every lines here, it's nothing but a streamline. One streamline we have which is passing through the stagnation point. What is that? It's a blue line. So also question they can put, what is the equation of streamline which is passing through the stagnation point? So automatically you have to understood they are talking about this blue line, they are talking about this solid surface. So here equation of streamline will be 0, because it will not allow the flow across the streamline. Okay, so and it is passing through the stagnation point, so automatically velocity will be 0. So it means there is no existence of a streamline here. There is no possible case of the flow. There is no existence of the stream function, hence psi will be 0. So for 1 marks, this is very important, you need to remember. This is the flow pattern for the flow past a circular cylinder. Okay, now coming to the equation is very important, and question they are asking from here, what is that? Stream function for superimposed flow, or we can write equation of streamline for superimposed flow. You can write superimposed flow, or you can write for flow passed over a cylinder. Now you are going to write equation. Now see, what is the equation for the stream function here? You can write psi of the circular cylinder. Okay, I can write circular cylinder YCC. So what is the Y? When you will get YCC circular cylinder? When you have a superimposition of uniform flow plus doublet flow. Doublet flow. When this combination you will have, then you will get the circular cylinder CC. Okay. So now you know very well what is the uniform flow Cartesian coordinate. It was, if you say this uniform flow intensity or velocity of this is nothing but V, and obviously uh, a doublet flow, that combination, you know what is the psi for the doublet flow? If you remember, it was minus 2 pi sine theta by r. This was the equation for a doublet flow. And what is the equation for the uniform flow? That also, you know, it was y. Okay, I explained many times, so you need to remember this. So this is nothing but y plus minus mu upon 2 pi. It's nothing but sine theta by r. Okay, correct. Now you just convert into polar form. So y, you know what is the y? Y will be r sine theta plus minus of mu upon 2 pi sine theta by r. Correct. This is the equation of the stream function here you are getting for circular cylinder. Right. Can take sine theta common. So what will be the YCC? Sorry, psi CC. Psi CC means uh, circular cylinder stream function. Nothing but you take the common. What common you can take? Sine theta. So you will have a VR minus mu upon 2 pi r, and this is nothing but sine theta. This is nothing but psi value. And I will show you when YCC will be 0. I will show you, that is secondary part. But general value of the general value of the stream function for the circular cylinder, you need to remember this is very special formula. Okay, and I will prove you like y stream function for that circular cylinder will be 0. That I will prove later on. So this is the equation of the streamline, or simply you can say stream function psi. Okay, for circular cylinder. Similarly, we can write the potential function also. Potential function.
Sir, last वाला equation दिखा दो.
Okay, I can't tell you how hurt and angry this makes me, but you've been late too many times. I'll need your keys.
Daddy, no, I'm
हो गया,
so
sir.
sorry.
Honey, I didn't even know.
Now we have a potential function for imposed flow. Now, what is the potential function for circular cylinder? It's nothing but when you will achieve, it should be combination of uniform flow plus combination of doublet flow. What is the combination? Is if you open this potential function for uniform, then what you will get? You will have here P into X plus what is the phi potential function? Mu upon 2 pi. If you remember this formula I had given, cos theta by r. Okay, x you just convert into polar form. Nothing but Vx is nothing but r cos theta plus mu upon 2 pi, okay, cos theta by r. Can take cos common here, so it's nothing but Vr plus mu upon 2 pi r, and it's nothing but cos theta. Is nothing but pi c. This also very important. This potential function for the circular cylinder, very important. This is the potential function for superimposed flow. What is the superimposition? It's a superimposition of uniform plus doublet flow, which is nothing but superimposed, which is nothing but circular cylinder. Once you superimpose this, then what you will get? Circular cylinder. So actually this is the potential function for the circular cylinder, right? Now coming to the coming to the one by one points, we'll see here. Coming to the uh, stream function first, which is nothing but passing through the stagnation point. Okay, and already we have taken psi value here. This psi cc is equal to vr minus by 2 pi r sine theta. Now any two things you can do. It's very easy. What you can do, you can find first stagnation point if you want, and then you satisfy theta and r value to this, then again you will get psi cc will be 0. That is the option you have. You can do by this way also. It's your choice in what way you want to write. It's your choice. Otherwise you can take the concept of stagnation point, like okay, equation of whatever the circle which is passing through the stagnation point. So equation of streamline, when it is passing through the stagnation, then psi will be 0. So if you make psi is equal to 0, then you can get the r value, simple. Okay, and theta value. So any option you can choose. I will tell you one which is very simple. I can calculate velocity here. I will get velocity, then I can show you for stagnation point velocity will be 0. Then I will find stagnation point, that is r and theta. Once you get r and theta and you keep r and theta value, then you will get psi cc. That also option we have. So better we'll find the velocity first. Okay, one by one you will understand. It's very easy. Two velocity you will have. What is that? It's a radial velocity and tangential velocity. It's the radial velocity and tangential velocity. So I can write here first radial velocity, polar form. Okay, what is the radial velocity? So you know stream function as well as potential function also in terms of polar form actually. So what is the radial velocity? It's nothing but radial velocity will be vr. What is vr in terms of psi? So vr is nothing but it's a 1 by r. Just recall the formula, dou psi by the formula of radial velocity. Okay, now if you write radial velocity vr here, it's a 1 by r dou by dou theta, and psi value just now you have calculated. No, psi value just now you have calculated. What is that? Here this is nothing but psi value, pr minus mu upon 2 pi r sine theta. Pr minus mu upon 2 pi r sine theta upon pi r sine theta. Okay, to see what is the radial velocity. So radial velocity will can multiply r inside. So what you will get? So v. Okay, it's a v, and sine theta, because you are going to differentiate with respect to theta. So only sine theta you will have, that is cos theta. Actually here you can write, or you just take r 1 by r outside only, just differentiate this. Okay, once you differentiate, then what you will have? Sine theta will be only cos theta, because this sine theta is the common. Sine theta is what common for both. Here this sine theta is what common here you have taken. So only this sine theta will be converted into cos theta. Rest everything will be same. Pr minus mu upon pi r. These are in bracket, and this sine theta will be. That's all. Now r you can multiply inside, so it's nothing but b cos theta minus mu upon 2 pi r square. Mu upon 2 pi r square cos theta is nothing but r, which is nothing but radial velocity. Is nothing but radial velocity. All right. nothing but radial velocity. Now coming to this next, what I can write here, tangential velocity. Tangential velocity. So tangential velocity is nothing but again use the polar form formula for anyone, for you can use potential function as well as you can use for the stream function. It's your choice. So tangential velocity, if you write, then it's nothing but v theta, and in terms of stream function, it's a dou psi by dou r. If you write, I can write here minus dou by dou r, and what is the psi? Just now you had written psi value. What is that? Psi is nothing but here. This is the psi Vr minus mu upon 2 pi r sine theta. Nothing but Vr minus mu upon 2 pi r sine theta. Okay. So once you differentiate this, then what you will get? V theta. Then it's nothing but dou by dou r of r. So only v you will have. So I can write it's nothing but minus minus of v. Then minus minus it becomes plus, multiplied by here, bracket open. So and keep sine theta outside better. Minus v, and then minus minus plus, here it comes mu upon 2 pi r, and you just differentiate with respect to r. What you will get? So mu upon 2 pi r square, isn't it? Minus will come now, because 1 upon r differentiation is 1 by r square, minus 1 by nothing but minus. Take it, it's a simple differentiation. Minus mu upon 2 pi r square you will have, and obviously outside we have a outside, or you can have what is the value you are getting? Take so minus v you take common, so what you will 1 plus upon pi v r square. Write this, right? You can write this. So this is nothing but tangential velocity with it. Now you know the stagnation point concept. This is the tangential velocity. Take the differentiation, can open the bracket, separate also you can do this. Now what is the stagnation point? So stagnation point, you know the definition. Stagnation point is the point, stagnation point is the point where velocity will be zero. What velocity? All velocity. All velocity means the, if it is radial velocity, so PR radial velocity will, it is tangential velocity will be zero, resultant velocity are also are all zero. So totally what you have to keep, you have to make it zero. That's all. Radial velocity, tangential velocity, or resultant velocity. Now you see what is the, just now you achieve it. What is the tangential velocity you got here? By the tangential velocity only we can start with. What is that you have here? See, just now you got minus v in bracket 1 plus mu upon pi v r square sine theta equal to 0. If I say tangential velocity becomes 0, so maybe this part is 0, or maybe this is 0. First part cannot be 0, no? Because first part 0 means velocity is 0. Yes or no? Otherwise rest are constant. mu is constant, radial r is constant. So obviously mu is nothing but the strength of doublet. So maybe doublet flow is 0, or maybe uniform flow 0, but it is not 0. It is existing doublet flow is also there and uniform flow is also there. It is not 0. If it is 0, then there is no superimposition, obviously. So that means this first part is not 0. What is 0? Second part. So that means sine theta becomes 0, because we are talking stagnation point. So this v theta will be 0. So that means it's a sine theta is 0. Means sine theta is what? Not this first bracket. Because first bracket 0 means maybe maybe doublet flow is 0, or maybe uniform flow is 0. But both are not 0. Both are not 0. So that means sine theta is what? 0. If sine theta is what? 0 is 0, it means theta will start from first pi, and theta is also pi, as well as minimum value you can see sine 0 is also 0. So 0 and pi, 2 points you got. It's nothing but stagnation point. Stagnation. How I can show you? Go to the diagram here. Easy. Understand. I can take this radial distance anywhere point. I can show you here. Somewhere this I am considering one point x comma. This distance, radial distance is r, and this angle is what? Theta. If theta makes 0, then stagnation point S2 you will get, and theta make pi 180 degree, then S1 you will get. That is also true. By diagram also it is true. So how many stagnation point you have? It is 2. With respect to the theta, it's nothing but one point is what? At 0 degree, another is nothing but radian value pi or 180 degree. Both are correct. Theta is 0 degree and theta is nothing but 180 degree. 180 degree. Okay. So these two are the stagnation point. Similarly, if you see like what should be the if you check radial velocity, okay, then radius also you can get from the tangential velocity. You got theta. Similarly, you can check this value of uh, here uh, radial velocity, where it is here. Radial velocity you can check. Radial velocity, right? If you keep this radial velocity, so what you can write? Me write this value, radial velocity cos theta we can take common, so it's nothing but, or v cos theta you can take 1 minus mu. I will write again radial velocity here. So you have radial velocity, which is nothing but, just go back and to take v cos theta common. So what you will get? To take v cos theta common, v cos theta common, so what you will get? 1 minus upon 2 pi. To take v cos theta common, so radial velocity cos is, right? So v cos theta 1 minus mu upon 2 pi v r square. Here this pi v r is you will get here. Okay, you had seen that the value of uh, theta becomes 0, okay, for the stagnation point. For the stagnation point, because radial velocity you want to show that radial velocity is what? 0. Yes or no? Radial velocity you want to show 0 at stagnation point. You can write here at stagnation point. At stagnation point, this radial velocity should be 0. I will show you. This radial velocity should be 0. Yes, obviously. And at stagnation point also you got that angle. Okay. If I keep angle, so what is the angle you have? V cos, angle you got theta. Theta at stagnation point you got 0 and 180. Anyone you can take. I am taking 0. So it's a cos 0, 1 minus mu upon 2 pi v r square, right? You see here it is nothing but v You just open the bracket. So v minus, because cos 0 is what, 1. So v, you will get minus mu upon 1, v will be cancelled out. So you will have a 2 pi r square. Okay, equal to 0 here. What you will get, mu upon 2 pi r square is equal to v you will get. See, right? Then what will be the r? So r is nothing but, if you see, value of r, nothing but mu upon, check nicely, understand, 2 pi will, v will come in denominator because r square you have taken, right? And it will be in root. See this. So what is the your r radial distance? Mean, because it's a circle there, okay, it's a circle, this proved itself. Even though I can show you by the angle also. Can you tell me what is the cos 180? Cos 180. Anybody? Cos 180. So theta is equal to 0 you have taken. Then you got the radial distance, and that radial distance is nothing but r is equal to mu upon 2 pi v, root of mu upon 2 pi v. You got this radial distance when you have taken theta is equal to 0. Now at the same stagnation point, at stagnation point only, just have a patience, just give me 5 minutes, I will show you everything related to this. At stagnation point, vr will be 0. Now I'm taking, because stagnation point we have a theta is equal to 0 and 180. So first I have taken 0 degree, cos 0 I have shown you. Now I'm going to show you cos 180 what will happen. So vr is equal to, what is the formula? It's nothing but v cos 180. Inside this, it's nothing but 1 minus mu upon 2 pi v r square, right? What is cos 180 degrees? Cos 180, vr is 0. What is cos?
minus
So it's nothing but minus v. Now in bracket you got 1 minus mu upon 2 pi v r square. Here you can write minus v is equal to minus v, then plus mu upon 2 pi v cancel out, the r square is equal to 0. Again if you solve r, then you will have nothing but r. What is the value of
same ही आएगा
it's nothing but, take, what is the value here you got? It's a mu upon
by 2 pi v
2 pi v
square.
n root. So now it's also very clear. I will show you like what you have got here. See, simply I have drawn the flow pattern, and I told you like if source and sink are 2a distance apart, then you will get oval body. And once it is approaches to 0, distance between source and sink approaches to 0 becomes doublet, then shape will be the circle. I have told you and you have accepted, and obviously it is correct also. So but flow pattern you have drawn, that is true, but mathematically how you will prove this is circle? Somebody can ask, no, it will not be circle, it will be some other shape. Then how you will prove? Now this is the mathematical proof of it. I can show you here. 2 points you have taken, one is 0 and one is 180 degree. I will show you here. You have taken 2 points in between origin, can take, you have taken 2 points, one is 0 degree. Okay, this is the theta is equal to 0, and this is theta is equal to 180. In both cases you are getting the same distance. R is what? Same. Both cases R is what? Same. When it is possible, when it is a circle only, then only possible. Yes or no? When it is circle only, then then this radial distance will be same or not. Circle बनाओ यार, समझ में आ गया ना मैं क्या बोलना चाह रहा हूँ? So
हाँ सर.
yes, radial distance for theta and 180, because theta and 180 is just opposite. Okay, so it will be same, radial distance will be same. It means its shape is nothing but a circle shape, something like this. Here also theta is equal to 0, and here also theta is equal to 180. Both side, both cases, you will get the same radial distance. You will get the same radial distance, and it's nothing but r. That means its shape is nothing but circle. This is nothing but circle. I'm not able to draw. Now what is the radius? You got that circle, and r radial distance also you got. Now if I say what is the value of this radius, then it is nothing but, I will draw now one circle. Now I can show you 2 points. This is r for theta is equal to r for theta is equal to 180 degree, and this r is nothing but, you can say, radius of circle. Because if it is oval shape, then this r will not be same. If it is nothing but circle only, then it is possible. Hence you can say this r is nothing but radius of circle, radius of circle. And what r you got here? The radius of circle you are writing. This is also very important. Direct in examination they are asking this value. Okay, radius of circle. So now it's very clear. Once you combine uniform and doublet flow, then you will get circular flow, circular cylinder you will get. Okay, and that time what is the radius? So radius is nothing but a small r. Now you can say it's capital R also, and this value will be, check it, this value will be mu upon 2 pi v, mu upon 2 pi root. This is nothing but radius of circle. Obviously you also can say this radius small r is nothing but at surface, because this small r can be anywhere. It can be at this point also, but where you are finding this r, it is at surface. Maybe theta is equal to 0, or maybe theta is equal to 180. It means it's a surface. So this small r, if you write for the surface, it means you are going to talk about the full radius of the circle, which is nothing but capital R. So small r becomes capital R at the surface of the cylinder. This small r can be at any point. हाँ, वो बीच में भी हो सकता है. But if you are writing for surface, then this small r will be capital R. That capital R is nothing but radius of circle. It's mu upon 2 pi. This value they are asking. Okay, this value they are asking. Very important. The radius of the circle, whatever the circle you have achieved, that will be the obviously imaginary circle, but to calculate for that what is the radius, so it's a mu upon 2 pi v. All right, now all velocity, radial velocity and tangential velocity you can calculate. And one point which is very important, like you need to find the equation of this streamline also. If I'm interested what is the equation of this streamline, I can now write what is that equation of streamline for circle. This is very important. Equation of streamline for circle. Now check circle or circular cylinder size cc. Just you see somewhere you have written the value, na, size cc. What is that? Check. Size cc is nothing but, here you just remember this value. It's a vr minus mu upon 2 pi r sin theta. I can take a common of v, or directly value also I can write. It's your choice. Anything. I mean, I will write first value vr minus mu upon 2 pi r. No? vr minus mu upon 2 pi r sin theta. To keep data size cc. Where is the size cc? It's the surface of the obviously circle. So r value we can keep here. anything, theta you can keep or r you can keep, you will get your answer. So I can say if you take even the common also v value, if you take the common also, so what you will get? The small r minus mu upon 2 pi p into r. That also is correct. And this is nothing but sine. Okay. Now you see what is the radial value r. What is the radial value r at the surface of uh, circle? It's small r. Just now you have written root of mu 2 pi v. Mu 2 pi v. That is the value mu 2 pi v. It's nothing but root mu 2 pi root minus mu upon 2 pi v r. R value also here you can write mu upon 2 pi v, and it's nothing but sine theta. What is the theta at the circle? Okay, theta is maybe 0 or 180. So in both cases, if you write sine 0 or sine 180 also, this value will be 0. This value will be 0. Even though if you write value of r also nicely, in between whatever the value you will get, cancel out. Na? Complete r you write, calculate properly, you will get. But what I am doing, I am just taking sine theta, just want to simplify this. Sine theta value, and theta is 0 or 180 for this circle, because this circle is what passing from the stagnation point. Here stagnation point is 180 and here stagnation point is theta is equal to 0. Just I want to keep this 0 or 180 anything. So what is the sine 0? It's 180. What is sine 0? It's a 0. What is sine 180? It's a 0. So automatically psi cc you will get 0. For that reason only I have told you, whatever the circle you are getting here in flow pattern, directly I told you this circle will be treated as a solid surface. That means it will not allow the flow. So I had told you by the theory only, I had told you this psi will be 0. Here by theory only I had told you, because this circle is what treated now as a solid surface, it will not allow flow inside to outside or outside to inside. So I said psi will be 0. But now mathematically it is proved also. It is proved. See, psi cc now it is 0. So it's very easy there, but each and every concepts are very important. I mean, you can go and analyze the each and everything, and it's very feasible thing also. So I think for today it is done. Next class also will continue this, and one more flow pattern is what left. That is the rotating cylinder. But here, if you say, see, this cylinder is what only stationary cylinder. Okay, it's not a rotating cylinder. So here also you just need to remember, once you have superimposition of uniform flow and doublet flow, then you will get stationary cylinder. Okay, you can say here it's a stationary. Once you perform this superimposition, okay, superimposition if you perform only uniform and doublet flow, then you will get stationary cylinder. This combination will get stationary cylinder. But if you want rotatory cylinder, if you want this cylinder should come in rotation, then you have to use vortex flow also. You have to superimpose vortex flow also. Three flow will be there that time: uniform flow, doublet flow, and vortex flow. So that we'll see in next class. This I will continue. These two are very important: stationary cylinder and rotational cylinder. And they are asking question in GATE Aerospace as well as GATE XC. So one more lecture I need to explain the next one also.